So I wanted to try to demo this calorimetry lab for you guys. Maybe you've done one like this. I do it as kind of a small scale, quick hitting demo with, or lab, not a demo, with my kids. And so I use a little condiment cup that I got on Amazon. I got a box of 125 of them. They're 2-ounce dips and salsa cups, and it comes with lids. And I've since found that often you can go into a store, into a restaurant that has these and ask them for 20 or 30 and they'll give them to you. You'll just say, hey, I'm doing it for my school, using it for school for my kids, and they're happy to give you some, and the lids too. And so I take the lid and a pair of scissors and I work a hole in it for the thermometer. Just a regular thermometer, probably ones that don't need to be submerged a whole lot to get a decent temperature reading, but that may be one source of error. Now, this is kind of going to have a lot of error, and that's going to be great for your students to analyze all the sources of error in this experiment. It might be the way that you take it from being maybe an honors or college prep chem class into an AP chem style lab where they've got to do some error analysis and start thinking about it. But I at least wanted to demo this again. I wanted to demo it for you. So I've got my piece of magnesium, and it's about 8 centimeters long, and it comes out on my scale to be about 0.133 grams. And I just weighed it straight out. And that may not be very accurate depending on the scale. Oftentimes you need to measure out a meter of magnesium ribbon and then weigh that meter so that you can get a mass per length ratio to get a more accurate mass. You would do the calculation based on the length that was measured by the students. I also have not cleaned my magnesium ribbon either. And so there is some magnesium oxide on the outside. And again, if I'm demoing this or if I'm not telling my students what to do, that might be a good source of error for them to take note of, or for you to point out to them when their results aren't what they should be. I've got 2 molar hydrochloric acid, and I'm going to take about 10 milliliters of that. Now, the magnesium is going to be the limiting reactant, so the only thing you need to know is the exact volume of hydrochloric acid that you have. And yes, I should have goggles on, but it is way too hot in here, and I think I'm going to not wear my goggles, or at least not put my goggles on until the reaction starts. So I poured almost a perfect 10 milliliters there, maybe a half a milliliter under. So I'll go ahead and put that in my little cup. You could double these up, and that insulates it better, or you can let your students figure out, oh, maybe we should try it insulated a little better than this because we're going to be losing a lot of heat to the room. So now I will go ahead and put my goggles on. I'm going to take my initial temperature reading here of the hydrochloric acid. Now hopefully that's at room temperature. And man, are these goggles dirty. 26.1 degrees Celsius. Let me write that down. 26.1 degrees Celsius. As my initial temperature, I'm going to assume the magnesium is also at room temperature. I'm going to drop that in. Put the lid on real well. Maybe mix it around a little bit. I definitely don't want that thermometer too snug in there, otherwise the gas, the hydrogen gas that's generated isn't going to escape. So let's see, we're approaching 60 degrees Celsius so far. And I'm going to assume that my hydrochloric acid, even though it was 2 molar, is roughly, since it was about 10 milliliters, it's going to be about 10 grams. I'm going to keep mixing here. Take these off so I can read. I don't advise you doing that with your students. I can still hear the reaction going, but I think we have topped out at about 68 degrees Celsius. right on 68.0, and now we're beginning to drop. So I do want to look at this now, because often there's magnesium left over often before the temperature starts to go down. So I do want to pop this off real quick. Oh, and that time it finished. But I find that my students often don't look at that. They just think, oh, the temperature stopped going up, so the reaction must be done. And in reality, sometimes there's some magnesium left in there, so they need to look at that. So I've got all the data that I need. All right, I've got the mass of the magnesium, I got the mass of the hydrochloric acid, I've got the initial temperature and the final temperature, and now we can go about making those calculations. So now your goal here is to, A, find ways to make this into an inquiry lab for your students, because as written, it's probably too simple for AP level. And also I want you to come up with some good error analysis questions. I find with my students that if I just say analyze, right, what are your sources of error? Well, what do I get? Bad measurements, human error, right? All of those things that we really don't want them to say. We want them to go deeper in that. So I tend to, in my post-lab questions, present some error analysis questions like, well, what would have happened if all the magnesium didn't react? Right? And so then they have to think through what are the consequences of that for the results of the lab. And so I find that, again, if I seed them with some of those ideas and have them do that analysis, I get much better analysis from them. And that's really what I want. And that's kind of like the questions they're going to see on the AP exam too, where they're going to have to be stated with, well, what would happen if this happened? All right, well, how would that affect the final results? If you want to make those calculations and see how close we were to getting the accepted value of 460 kilojoules, go right ahead. All right, in theory, we should be under that because we lost a decent amount of heat to the room because this was not very well insulated. And again, that's another discussion you can have with your students. Now, if for some reason you end up with results greater than the heat of the expected enthalpy of the reaction, well, that's another discussion you can have with your students. And maybe we can have that discussion a little later on when we come back together in class once we look at those results and once you think about this lab a little bit more. Hope this was helpful.